talking about Python. And so, firstly, to write code in Python, right, you need to have an IDE or a text editor to write Python code. So, there are two requirements that you need to download. So, you can click on these links and you can find the download. So, the first thing is Python itself. If you click on the link, you will be taken to the Python website where you can download and install Python. So you go to this website, you click download Python 3.9.2, then you save it to any place on your computer, and then you run and you follow through the steps that it shows you. So you can install Python, and then after installing Python, uh, yeah, actually, let's take a minute to have everyone install Python if you don't already have it. 3.90 or 3.92, yeah, any of them is okay. Sorry? Yes? So what you have to do is once you've installed Python, you can also install VS Code. So since you already have VS Code, you don't need to do that, but the others will. So you go to this second page, and you can download VS Code, and you can pick uh, whichever version of Windows you have, or Linux or Mac. If you don't know which version of Windows you have, you can, I mean, which version of Windows, you just click this one, and I think the website will figure it out for you. So if you know which one it is, then yeah, you can go with the specific one. So either is fine. Once you have VS Code installed, you can proceed. Oh, okay, that's also okay. That's also okay. You can use any ID of your choice. Okay, so I'll proceed. Once you have your ID set up and Python installed, you'll actually start with the uh, session. And so the first thing that I'm going to talk about is like the very basic thing that you need to know about Python is constants. So to do anything in a program, right, you need constants, and any value that remains the same throughout the execution of the program is known as a constant. It literally is a constant. It doesn't change. Okay. And for example, like 10 is a constant. Every number would be a constant because numbers don't change. Uh, then we have variables, and variables are like boxes that you use to store constants inside. So it's a container that you can put one constant into, and then you can take it out and put another one in if you wanted to change it. So a variable is the value that can change during the execution of the program, because remember, it's like a box. You can put something in, you can take something out, and you can change it as many times as you like. And here is an example of using variables. So I have a equals to 10. So a is my variable name, and like a, b, c are my three variables. And a is 10, b is 20.5, and then I add a and b together, and I assign them to c. Okay, so to be able to see what these variables actually, the value of the variables, we need to print them to the screen. So we use this function called the print, and you write the name of the variable inside, and it'll show you the value of the variable. So you can use the button to copy the code if you want to test it, and you can paste it into your IDE. And if you're using VS Code, then after you paste the code into your IDE, actually you will need to write the code in a file called a Python file. So basically, you can make a Python file by making a new file, and then you can write any name that you want here. And the extension should be .py. So when you create a text file, it'll have .txt, but you will need to change it to py for it to work. In case you don't see your extensions, then you will have to click view at the top there, and then click on this checkbox which says file name extensions. So if I remove that, then you see the extensions disappear. So if you don't see your extensions, you need to click that for them to appear. Okay? Yes? Okay, so once you have your code pasted into code, you can open the folder that the code is in, and once you're inside a folder, you can go to you click on the path of the folder, and you type cmd, and it'll bring up a command prompt, and this is what we'll use to run the code for Python. Okay, so if you have any questions regarding how to open the command prompt, please let me know. So you can open your folder in which the Python file is located, and then use cmd. Uh, Uh, yes, so you you go to the folder in which your Python file is located in. So for me, that's this folder. So once you have your folder open, you click the path of the folder at the top. This place it says this PC desktop Python, or it can be different for you. But you click here and type cmd, and then you press enter, and it'll bring up the command prompt. Okay, so once you have the command prompt, you can paste the code into VSC, save the file, and then to run the code, you type Python and then the name of the file. So for me, it's test.py. So I'll type that, and then I type that, it'll run whatever code I had in this file. So in this particular program, I just went over it. I'm taking two variables that are assigned to 10 and 20, and then I add them and assign them to a variable called c, and then I print the value to the screen. Then I subtract a from b, and then I reassign it to c, and then I print it again. So first I add them together, I print them, and then I subtract them, and then print them. Okay, so uh, you can also so these are storing numbers, right? You can also if you want to store a word or a sentence, you can also do that, and you use double quotes to write a word. So when you want to write a word or phrase or a sentence, then you uh, you use your variable and you assign the value, and you whatever word or phrase that you want the variable to have, you put double quotes around it. Okay, so if I now run this program, it'll print out the value that I typed in here, and these sentences or phrases or words that I type in a program, they're known as strings. So this variable a is known as a string. Okay, You can also make lists with Python. So if you want to store multiple variables or multiple constants in the same variable, then you use this kind of a notation. You write square brackets, and then you type your values in, and you separate them with a comma, and that makes a list in Python. So every variable, right? Remember, they're like boxes that store values. So every different type of value that you want to store requires a different type of container to be stored in. So if you, yes. I was supposed to ask this list, does it give all the same data type? First one, this is the first one thing. The second one is the third one is no, in Python, you don't. They don't have to be the same data type. So if I actually run this one, it doesn't give me any errors. So Python, you can have lists that have multiple data types in them. So usually in any other programming language like Java, you're not allowed to do this, but in Python, you can. So yeah, so now you have variables, right? Variables, they store different types of values in them. So you can store integers, and you can store words and sentences and strings. So each type of value that you want to store in a variable, it requires a different type of variable. It's just like if you want to store water, right? You can't store water in a plastic bag. You need a water bottle to store water inside. So every different type of value that you want to store requires a different type of variables. And this formally in Python is known as a data type. So your each of your variables has a data type associated with it, which describes what kind of value it stores. So there are there are about I think 9 different data types in Python, 7 of which I'm covering for today, because the remaining 2 are kind of out of the scope. But these are the most commonly used data types anyway, so it's okay. So the first one is an integer. So an integer quantity is any value that can be negative, positive, or zero. So it doesn't have any fractions or decimal parts. So it'll never have a 0.5 or a 0.4 or something like that. Then you have floating point values. So floating point values are values that can store fractional parts as well. So you can have 1.5 or 2.5, and those are all floating point values. If you have any questions, then please ask. Uh, if not, then I'll move on. Then you have Boolean values. So a Boolean value is a data type that can store only two values, either a true or a false. So basically, it's used for when a computer needs to answer a yes or no question. So let's say I ask, do you have a pen? Then you either have a pen or you don't have a pen. So you either say yes or you say no. So when a computer needs to answer a yes or no question, it uses a Boolean data type. So it can be either true or it can be either false. So and Boolean data types are quite important for conditions and like all of programming. So we'll be taking a look at conditions later on. If you have any questions, please ask, and I'll move on. And we just saw a string is also a data type in Python. It's any word or phrase, and a string is always enclosed by double quotes. You can also assign a string by enclosing it in single quotes in Python. And if you want to use a string that has multiple lines, then you use triple quotes to do that. So you have triple quotes. You can either use double quotes or you can use single quotes. Both of them work. So when you have a string, right, you can, if you, let's say, if you have a string and you want the fifth character of the string or the 10th character of the string, you can do that by using what's called a subscript. So if I have a string that's A and I say I want the first character of the string, I write A uh, with a subscript of 0, and that gives me the first character. Why 0 and why not 1? Is because in programming, in general, in any programming languages, right, a list or any numbered uh, or any ordered list in programming, it starts with 0. It We never start with 1. So in a list or in a string or in any other data type, you will always see that it starts with 0. Okay. So 0 is the first. 1 is then the second character. 3 or 2 is the third character. 3 is the fourth character, and so on. Does that make sense? And in Python, you can also have negative indexes. So if you want to get, let's say, the last character of the string, then you use an index of -1. So that tells Python that I want the last index of the last character of the string. And you can use -2, and that would be the second last character. -3 would be the third last character, and so on. Does that make sense? Well, if you wanted to obtain a particular part of the string, let's say if you want to obtain characters 4 to characters 8, then you can do that using what's called string slicing. So this is the same as using substring in any other programming languages, if you're familiar. So you use slicing and use the same kind of notation that you do with indices, and you say that if I have a string, then writing this kind of a notation gives you uh, it starts the string from the the fifth character of the string, and it ends at the ninth character of the string. So you need to remember that it starts at 0 and not 1. And the last character of the string is not included in the result. So if you do this with a string, then this one will always start from this and end at this, but it's not in the end is not included. So does that make sense? And if you wanted to take a part of a string that starts at some point but ends at the end of the original string, then you can just omit the last number, the second number, and it'll start at the fourth character of the string, and it'll end. You just don't say you don't specify where it has to end, and it'll take the rest of the entire string. So this one would print um, start from the it um, starts from the fourth character and goes all the way to the end. So the fourth character for the string is S, and so you get this part of the string. And if you want to take a part of the string that starts at the beginning and ends at a point before the end of the string, then you can omit the initial value of the subscript, and you'll get you'll get a string that starts at the beginning and ends at whichever position you specify. So this one starts at 0 and then it ends at the 6th character. So it takes this much of the string. That makes sense? Okay, so you in Python you can also, if you want to pick particular characters from the string in a particular interval. So let's say you want to pick the first character, then skip 2 characters, pick the third one, skip another 2 characters, pick the 6th one. Then you can do that uh, by specifying a third number in your string slicing. And this one it'll start at the third character of the string, and it'll go till the 10th character of the string, and it'll skip every 2 characters. So when you do this, you will get the third character, then the 6th character, then you'll get the 9th character, and then it'll end because you specify the end has to be at the 10th character. Does that make sense? And you can actually, this is quite powerful because you can use negative values here as well. And if you don't specify any values for the start and the end, and you use -1 for the third value, the entire string will get reversed. So it's the same string, but it starts at the end and goes all the way back. So you get the string, but it's actually reversed. And lastly, with strings, if you want to know how long a particular string is how many characters the string has, and you can use the len function in Python, and it gives you the length of the string. So for this one, it has a length of 24 characters. Okay, and if you ever have any questions, please ask. And yeah, if you the best way to learn these things is to try it yourself. So if you ever find that you don't understand something, you should always copy the code that is provided here and then try it out for yourself, like write and play around with the code a little bit, change the values, see how the code behaves. And if you still can't figure it out, you always ask questions. So we'll move on. You can join multiple strings together to form one string, and this is known as string concatenation. So you just use a plus sign, and it joins the strings together. So I have my sentence is in 3 different parts, and I use the plus sign to join them together, and I get the full sentence, which is this is known as string concatenation. Okay, so what would happen if you try to access a position of a string that is larger than its length? So let's say here um, you try to access the 20th character of the string or the 21st character of the string, but the string is not that long. What would happen? Python would give you an error if you try to do this. It'll say that the string index is out of range. Sorry? Okay. Then we'll move on to lists. And lists is basically a list is an ordered collection of different constants or variables, and each member of a list is formally known as an element. of that list. So, for example, this is a list, and uh, it it has numbers, it has floating point values, it has strings, it even has another list inside. So a list can have other lists inside of it as well, and each value of a list gets assigned an index, like just like a string. So the first value, which is 2, is in index 0. The second value, which is 3.4, is index 1. The third value, which is this is a list, the string, is index 2, and so on. So every value in a list has an index. And in general, when you initialize a list, right, if the list is too long to fit in one line like this, it's not easy to read the list, right? So a good practice is to write out the list with the elements separated out in multiple lines. So you do this only when the original list is too long to read. You don't need to do it all the time, but it's a good thing to do when it's too long to read in one line. So lists work similarly to how strings work in Python. So you can use indexes to get the values of a string exactly the get the values of a list exactly the same way that you use them on a string. So you can, you use subscripts. So 0 will get you the first element, -1 will get you the last element, and slicing also works exactly the same way. So 4 colon 8 will start at the fifth element of the list, and it'll end at the eighth element of the list. Okay, so it works exactly like how a string works. So if you want to combine two lists together, two or more lists together, you can use the plus operation, and that gives you one big list. It combines the smaller ones together, and it's exactly like how strings work. So if I copy this and run, and I just get one list with all the 6 values. Hey, if you want to add an element to a list, you can do that using the append function of the list. So when you use this, it adds an element to the end of the list. So now if I run this, you see that C gets added to the original list. So usually in Java or many programming languages, you can't change the size of a list. So in Python, that's not the case. In Python, your list, they can be of any, like you can change the size of the list. So they're not restricted to a particular size. You can keep on adding more elements to the list if you wanted to. So I can add, and it'll work. So yeah, you can add as many elements to a list as you want. It doesn't have to be of a fixed length. Then if you have two lists, and using the plus operation on a list, you get a new list. When you use the plus operation on the list, you get a new list that's combining all of the lists together. But if you want to modify an existing list to have the additional values, then you can use the you can use the extend function of the list. So you type a dot extend, and then you type the name of the second list that you want to add to this. So if I type B, and then I write, and then I print the value of A, it'll be A, and then it'll have the second list added to it as well. So I get the 4 values. Okay. And it works the same way when you try to access an element of a list that is out of it's more than the length of the list. So if you have a list of length 4 and you try to access an element that's not like it's longer than the length of the list, then you get an error in Python. So it gives you index error, list index out of range. Yes, exactly. So append, you can only give it one value and it'll add that as a single element to the list. So if you give append a list, right, it'll work, but that'll become another list inside the list. So if I do append and I give it a list, let's say 10, 19, or 20, something like that, and I run this. I didn't print the value, sorry. And now if I run this, then you see it does get added to the list, but it's a single element. It's not a continuation of the list. So when you use append, whatever you give append to add to the list, it'll get added as a single element. If you use extend, then it'll extend, like it'll continue the same list, so it won't be nested. Yeah, so it'll become three independent elements of the list. So then we have tuples in Python. So tuples are exactly like a list. The only difference between a tuple and a list is that tuples, you can't change their values once you initialize them. So in programming, we say that a tuple is immutable, which means once you declare it, once you assign it a value, you cannot change it again. So if and once again, it's the same thing with the list. If you have a long tuple, then it's a good idea to spread the code out on multiple lines. So it's more readable and easier for people to read your code. So I can paste this in. And yeah, accessing elements from a tuple is exactly like how it works with lists. So every element in a tuple has an index. The first one is 0, the second one is 1, the third one is 2, and so on. And you can have lists inside a tuple as well. You can have tuples inside a tuple as well. So, um, and when you want to obtain a single element from the list, you do that exactly the same way that it works with lists. So slicing works exactly the same way, and like everything else is just the same. The only difference is that you can't change the values of a tuple. Yes. Yes. And one interesting thing to note here is that while you can't change the immediate values inside a tuple, if there's a list inside the tuple, you actually can modify the values. So if you see the last element of my tuple here is a list, and if I wanted to, I could change the value of that list, and it would actually work. Yeah, this is not something that comes up too often in Python. So this is like the only exception to the rule that you can't change values inside a tuple. Okay. So lastly, we have dictionaries. So dictionaries in Python basically store a key value pair. So they create a map between specified values, so to say. So um, basically, if it's unclear right now, it'll become more clear as you go through the example. So basically, to define a dictionary, you write it like this. And similar to lists, you can also write this in one line. But usually with dictionaries, it's always you write different elements out on different lines. You don't write them on the same line. So the value on the left is known as the key, and a value to the right is known as the value. And basically, what this does is if you now give this value to the dictionary, it will give you back the value on the right. So if you give it the key, it will give you the corresponding value. So to say, yes, you have a question? Yes. So for keys in a dictionary, you can use strings, you can use integers, you can use floating point values, and you can use tuples as well. You can't use lists inside a dictionary though. That wouldn't work. As a key, you can't use lists as a key in a dictionary. You can still use a list in the value of a dictionary. That would work. So when you declare a dictionary like this, you can access the values of the dictionary by specifying the keys as indexes. So it works similar to how a list or a tuple works, just that instead of having an index that starts with 0, 1, 2, 3, you use whatever key or whatever index that you specify. So um, if I run this, it'll print out all of the values of the dictionary. And with dictionaries, you can't you can use almost every kind of value inside a dictionary as a key. You can't, however, use a list. So if I try to use a list in a dictionary as a key, that will not work. So if I try to do that, then it says that unhashable type list. It just means that you can't use list inside a dictionary as a key. You could use the list as a value if you wanted to. Say, I say, um, so that this would work because you can use lists as values, and you see the list appears in the output. So uh, to use a dictionary, you have, it's basically, to summarize, it's a key value pair. You have a key and you have a its associated value, and when you give the dictionary the key, you get back the value. And let's say you try to access an element in the dictionary that doesn't have any key associated with it. So let's say I use one, but there's no one in my dictionary. What's going to happen? It's going to give me an error if I try to use a one. So it says key error one. This means that there's no key related to one in my dictionary, so I can't do this. Um, Another way to obtain values from a dictionary is to use the get function. So you can do a.get and then specify the value of the key, and you'll get back the associated value. An advantage of using the get function over that subscript notation is that you can specify something that's known as a default value as well. So if you specify a key and it's not found in the dictionary, then your default value is used instead. Does that make sense? So now that we've talked about the most common data types in Python, if you have a variable and you want to know which data type it belongs to, you can do that using the type function. So you write type and you give it the variable, and it tells you which data type it is. So The first one is a string, so it prints str. The second one is a float, so it prints float. The third one is a list, so it prints list. The fourth one is an integer, so it prints int. The um, fifth one is a tuple, so it prints tuple, and it prints boolean for the last one. There's no dictionary in here. I'll quickly write that. So if you have a dictionary, then and it'll print which means dictionary. And for now, you don't have to worry about what the class part means. We'll come to that later on. So yeah, this tells you which data type the element that you gave it belongs to. Does that make sense? Okay, let's move on now. So when you write a program, right, there are some variable naming rules and conventions that you must follow, and um, these are rules that are set by the programming language that you absolutely have to follow when you write variable names. And there are some conventions as well that are kind of unwritten rules. They are like they're not set in stone. You don't exactly have to follow the conventions, but it's good practice to follow the conventions. So the rules that you absolutely must follow, they are the first four. These four rules. So in variable names, right, you can only use letters, numbers, and underscores. So you can use a letter in a variable name, you can use underscores, and you can use 1, 2, 3, or any numbers that you want, and that works. So this is a valid variable name, so to say. So something like this would work without any issues. Then your variable names can't start with a number. So if you write a variable name that starts with a number, then it VS Code already gives me an error. It doesn't like when you do that. So oh, I didn't save. Now it should give me an error. So yeah, in so Python gives you an error when you try to do that. It's invalid syntax. You when you write variable names in Python, then the variable names, they are case sensitive. And basically, what case sensitive means is that A is a different variable than capital A. So both of these variables, they are different. They refer to different values. So um, variable names are case sensitive. And lastly, your variable names, they must not be keywords in Python. So keywords are basically reserved words in any programming language which have a specific meaning or a special purpose in the programming language. For example, int, it's a keyword in Python because it's the name of a data type. You can't use int as a variable name. That would not be correct. While these four are the only like laws or rules that you absolutely must follow, there are some conventions that it's nice to follow them, but you don't have to follow them, but you should because it's good practice to do so. So let's say if you're writing a variable name that is just one word, it's conventional to just use a all small letters. So radius or name or something like that. If you are writing a variable name that consists of more than one word, then it's conventional to use underscores to separate the words. So this is known as snake case. In Java or some other language, you'd use camel case, but in Python, it's conventional to use snake case. So you write all of your different words in small letters separated by underscores. And when you're writing a variable name that's supposed to be a constant, or a value that you don't intend to change throughout your program, then you use all capital letters. So let's say pi or golden ratio, they are all capital letters. You don't use small letters to write those. Of course, if you wanted to, you could use small letters as well, but it's nice to follow these conventions. And lastly, it's good practice to write variable names that are mnemonic, which means that they should indicate to a casual programmer their purpose. So using single letter variable names is discouraged, and usually you should only use single letter names when it's a throwaway or a temporary variable. So if you want to write code, then sorry. Yeah, exactly. You should use proper names that tell you what the purpose of the variable is. Yeah, your variable name should be descriptive, and it should be like people should be able to read your code and see at a glance what your variables or what your code tends to do. Okay, let's move on to operators in Python. So Python offers 7 different types of operators. We'll be going over 6 of them today. One of them is a bit out of the scope for today's session. But if you're interested, you can always look it up and read about it on your own. So the first operators or the operations that we can perform is arithmetic. Obviously, we have numbers. We should be able to do calculations with them, right? So you can do addition, subtraction, multiplication, division. Um, you can do integer division and something known as a modulo in Python in most programming languages. So let's go over all of these one by one. Addition is pretty simple. It adds 2 values together. So this would give me 15. Then subtraction is also pretty simple. It subtracts 2 values. Multiplication would multiply 2 values, and division would divide 2 values. And the integer division is the one, it gives you the quotient of a division. So if I do 17 by 6, this would give me 2 because that's the quotient of the division. So basically, yeah, it'll become clearer as I walk through the. Yeah, exactly. It gets rid of the floating point part, so it gives you an integer value. Because normal division in Python will give you a floating point value, so that will give you 2.5. In any other programming language, usually this is you don't have integer division. The normal division works like that, and you have to specify when it has to be either one of the two. But Python simplifies that, and it just has 2 different operations for it. So this will become clear when I run the program, and you'll be able to. Uh, it'll be more clear when I go through the example. So then you can do. You have the modulo operation, which gives you the remainder of the division, and the last one is exponentiation. So you can, yeah, it's basically the first number raised to the power of the second number. So if I run this program, then I get the first one is addition is 15, the second one subtraction is 5, then multiplication, and then division. So when you see the division here, it gives me this one, gives me 2.5. So it gives me the precise answer of the division. The second one, however, 17 by 6, it 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 would if I did normal division on that, it would give me the precise value, which is 2.8333. But when I do integer division, it gets rid of the floating point part, and it gives me just the integer part. So it doesn't round off, so it just gets rid of the floating part completely. The modulo operation, it gives you the remainder of the division. So when you do 10% 6, it divides 10 by 6, and then whatever the remainder is, that's the value of the modulus operation. And then lastly, there's exponentiation. So 5 to the power of 2, which is 25. Okay. Uh, if you have any questions, then please ask. I think it should be clear, right? No? Sorry? Uh, well, what's your question? Sorry? Oh, okay, okay. Oh, okay. No question. So if you have no questions, then I'll move forward. Then you have relational operators in Python. So relational operators are basically they allow you to compare the values of two different variables together. So let's say I have two variables and I want to find out if a variable is larger or greater, then you can use relational operators. So questions like is A greater than B, is A equal to B, they're all answered using relational operators. So there are 6 different relational operators in Python. So let's walk through them one by one. So you can test if variable is greater or smaller. So if I write 5 is greater than 6, this is going to give me false because that's not true, right? 5 is not greater than 6. If I run this, I get false because it's not true. So these are the types of questions or operations that use Boolean data type basically. That this is the purpose for Boolean data types. And I could also say is 5 less than 6, and yes, that's true. So it'll give me an answer of true. So there are four other data types or not data types, sorry. There are 5 other relational operators as well. So you can do greater than, you can do less than, you can do greater than or equal to, which you can do less than or equal to. You could use you can use equal to, which double equals to, which basically checks if two numbers are equal, and you can use not equal to, which checks if two numbers are not equal to each other. So uh, to recap, the greater than operation tells you if a number is greater than another one or not. The less than operation tells you if another number is less than another number or not. The greater than or equal to operation tells you if one number is either greater or equal to another number. The less than or equal to operation tells you if a number is less than or equal to another one. And the double equal operation just compares two values and checks if they're equal or not. And the last one does the opposite of the equal to. It just checks if two values are not equal to each other. So if I run this, uh, I get false because 5 is not greater than 6. 10 is less than 11, so yeah, I get true. Then 10, it's greater than or equal to, so it's equal to 10, so I get true. Then 2 is less than equal to 11, so I get true. 10 is obviously is equal to 10, so I get true. And then 11, it's not equal to 10, so I also get true. Does that make sense? Yes, the relational operators work for strings as well. So if you use a string with the relational operators, then it basically tells you if the strings are in alphabetical order or not. So this would give you true because A alphabetically comes before B. So if I run this, I will get true because A is alphabetically comes before B. Um, this will also work with longer strings. If I use A and then AAP, the first one still it alphabetically comes before the second one, so it will give me true. can use relational operators for sorting values in a list, or they use everywhere basically in programming. It's quite useful. Then we have Boolean operations. So Boolean operations in Python is basically is asking two questions and seeing if both have some. It's basically to see, like, you can say to write an email to someone, right? You need to have a computer and you need to have an active internet connection, right? So to write an email, you must have a computer and active internet. So the and here is the Boolean operator basically. If you have, if you want to uh, paint a picture or draw a picture, then you must have paper and you must have paint and you should have a paintbrush, right? So whenever there are things or whenever there are conditions that must all be true together, then we use and. So to play a video game, you need to own a computer or own a gaming console. So basically, that means that if you have either one, you can play a game, right? You can play a game on a gaming console, or you can play a game on a computer. So you can use or, and you can combine ands and ors together. So to draw something, you must have a pencil or a pen, and you should have paper, right? So these ands and ors that we use in English language, basically, they what relate. That's what Boolean operations in Python are. So in Python, if you have two different conditions, then you can use Boolean operations. So if I say 5 less than 6 and 4 greater than 2, then this would give me true because 5 is less than 6 and 4 is also less than 2. So I run it, I get true. So if I say all right, then only one of them needs to be true for me to get a result. So now if I say 5 is less than 6 or 2 is greater than 4, then obviously 2 is not greater than 4, but still it'll work because 5 is less than 6. So either one of the conditions can be true, and the or would give me a true. So it still gives me a true. If both of my conditions were false, though, like 6 is not less than 5, neither is 2 greater than 4, then it would give me a false. Okay, does that make sense? Uh, there's no Boolean operation for XOR, but there's a bitwise operation for XOR if you want to use that. So in Python, there's no XOR for um, Boolean operations, yes. So the Boolean AND is used to check if two or more Boolean values are simultaneously true. And you use it like that. You just say A and B, like you just saw. And this basically checks if both A and B are true. Like it makes sense, right? It's basically English. So this is known as a truth table. Basically, is a combination of all the input and output values. So here it shows you all of the different values that A can be, and then it shows you all the different values that B can have, and then it shows you the result when you do A and B, right? So if both of my values are false, then A and B is false. If both of my if one of my values is true and one of my values is false, then the result is still false. And if I have both of my values are true, then only then my result is true at hand. Okay, does that make sense? Note that and is not limited to just two variables. You could have three, four, or however many variables as you like, and you can just do and for an expression like this to be true, A and B and C and D, right? All of A, B, C, D must be true. So with this, you can try writing a truth table for four inputs and see what kind of a table you have. If you want to try writing it, then a hint is that you'll have uh, 16 different uh, um, 16 different combinations of input and output pairs. Okay, then we have the Boolean OR operation, and this is used to check if one or more of the given Boolean values are true. So you can use it like A or B, and here A and B are Boolean values, and it checks if either A or B is true. If any one of them is, then the expression evaluates to true. So if you write down every combination of the inputs and outputs for A or B, you can write it like this. You have once again, it's the same table basically that we had up above. So um, you use A, and oh yeah, they should say or and not like that. That's incorrect. But use A or B, and if you have both of your values are false, then it's false. If any one of the values is true, then the result is true. And obviously, if both of the values are true, then it's also true. So, or is only one of the values needs to be true. And again, or like and it's not limited to just two variables. You can use A or B or C or D. And for that expression to evaluate to true, just one of A, B, C, D needs to be true, and it works. So I could have 6 less than 5, or 2 less than 4, or 4 greater than 2, and yeah, that would give me a true because just one of them needs to be true. Does that make sense? And yeah, these are just examples. So you can type them out and copy them into code and run the program if you want to, and you can play around with the values and see how they work. So it's this basically the same thing. But now instead of using values in the condition, I'm using variables. It's the same thing. So here, for the first one is A less than B. So 10 A is 10 and B is 20, and 10 is less than 20. So that's true. And C is 30 and B is 20. So C is greater than 20, right? So that is also true. And since both are true, I get a true. And it's the same way you figure out for the rest of them, right? And that's Boolean operations. Then there's membership operators. So basically, membership operators are used to test if a certain sequence is present in an object. For example, if let's say you have a character or a string, and you want to find out if they occur in another string, then you can use these membership operations. So water, it occurs in water bottles. So the first condition is true. The second one, water not in water bottle, that's false because water is in water bottle, right? So that will work. That will say that'll evaluate to false. And the next one, SpongeBob in SquarePants, that would give you false because the first string doesn't occur in the second one. And this last one would give you true because SpongeBob is not in SquarePants, right? So um, if I comment these values out, then and I print these four, then you see the first one is true, the second one is false, the third one is false, and the last one is true. Okay, and the rest these operations, they also work with lists, tuples, and dictionaries. So if you want to find out if a specified value is in a list or in a tuple or in a dictionary, you use them the same way. And when you use them with a dictionary, right, they check if the value that you give to them is it's uh, it's a key or not. So when you use it with a dictionary, so it checks if the value that you gave it is a key or not. So if I run the program, then you see that the last two, they are, the first one is true because 3.14, it's a key in the first dictionary. But in the second one, pi is not a key of the second dictionary. It's a value, but it's not a key. So for this to give you true, it has to be a key, not a value. Does that make sense? So if I wrote not in here instead, then it will give me true. The last one gives me true because it's not a key in the dictionary. Does that make sense? That makes sense, right? Okay. So that's membership operations, and you have assignment and shorthand assignment operations. Basically, what these are is when you use the equal to sign in programming, right? It's equal to 10 or b equal to 20 or something like this. It's you are assigning the value 10 to the variable a and you're assigning the value 20 to the variable b. It's not the mathematical equality statement. It's not saying that that's not a mathematical equality statement. So if I say something like a is equal to a plus 10, that does not mean that 0 is equal to 10. If that were a mathematical statement, that would not make sense, right? That's actually an assignment. What this means is that you add 10 to a and then you assign the value to a. So if I print the value of a both before and after my assignment, then it would give me 10 first because obviously it's unchanged. Then I add to it 10, so I get 20. Does that make sense? So this is an assignment. This is not a mathematical statement. Uh, so in Python, you have seven different types of shorthand assignment operations. Basically, they allow you to write the same thing that I write here, but it's more compact and it's faster to write. So it's known as shorthand operations. So the same thing, I can write a plus equals to 10. And it's the same thing that I just wrote. So uh, this is also going to add 10 to a. So if I print again, then you see I get the same result. It's 10 and then 20. And the same pattern, I can subtract a value. So I can subtract 5 from a, that gives me 5. I can multiply a by another value, let's say 4.9, that will give me 49. So I get that multiplies. You can divide. So I can divide a by 2, that will give me 5. I can use integer division as well. And if I had a value, let's say 7, now I would get 3. And you can use modulus here as well, and that would give you 1 because this is 7 modulus 2. So you have 1. Does that make sense? So basically, for every shorthand operation, this is the equivalent way to do it without using the shorthand. So a plus equal to b is the same as doing a is equal to a plus b. A minus equal to b is the same as doing a is equal to a minus b. So it works like that. Does that make sense? So there are two more types of operators in Python, identity operators and bitwise operations. And bitwise operations are a bit out of the scope of today's session, so I'll not be going over them, but if you're interested, you can look them up. And the other type is the identity operators, which we'll be taking a look at later on. Okay, now that we have variables and operations, the third most important part of Python is conditionals and loops. And basically, this is grouped under something that is known as flow control. So there are times in life and in any activity that you're doing, there are times when you would need to make decisions, right? Let's say you go to a class And in the class, if you have a pen, then you can write on a piece of paper, right? If you don't have a pen, then you'll borrow from a classmate, right? So if you forget to bring your pencil box or you don't have a pen, then you'll borrow from someone. So these conditions you need. So the condition is you need to have a pen, and if you have a pen, then you do one thing. If you don't have a pen, you do another thing, right? So it's a condition of having the pen, and based on the result of the condition, you do two different things. And there are times when you need to do the same in a program, and we use if else if something known as an if else if statement in Python to accomplish this. So let's say I have two variables here, 10, a equals to 10 and b is equal to 20. And I want to see if b is greater than a or not. If it is, I do something. If it's not, then I do something else. Okay, so this kind of these if else, they're used everywhere in programming. Basically, any time that you need to make a decision, you'd use these. So, for example, let's say I wanted to find the maximum of two given numbers, then I can do that um, using these conditions. So I say my maximum is I just say zero for now because I don't know what's going to be the maximum. And I say if a is greater than b, then my maximum is going to be a. Otherwise, it's going to be b. Does this make sense? So if I now print the value, it'll tell me which variable has the maximum value. So it shows me 20. And if I change these around and I make a equal to 200, then I get 200. So basically now, just by changing the values, my program is doing a different thing. So these conditional operators and like conditions and if statements, these are like a really important part of any program. So uh, it's important that you understand them properly. And so usually when you write if statements and else statements, you need to provide an indentation of usually four spaces to in your code. There's this indentation of four spaces. It tells Python what uh, what part of your code comes under that else or that if. So let's say I have more statements that are underneath the if, then I don't give proper indentation, right? Then how does Python know which ones come under the else and which ones are outside the else? It doesn't know, right? So the way that you tell Python that my maximum is under the else is you give four spaces, and the print, it doesn't have any indentation, so it's outside the else. Okay, does that make sense? So indentations are really important in Python. They tell you like which part of the code some thing might belong to. So the maximum is under the else, the print is not. And sometimes you can also use two spaces to give indentations, but usually four is more popular for Python. Then you can have an if that doesn't have any else statement attached to it. So you can have an if that's just like there's no else here. It's just an one if. So uh, you can check if a value is greater than another one, and then you do something. But if it's not, then you don't do anything. So if I run this, then it prints the value because b right now is greater than a. But if I change the value so that now it's the other way around, it doesn't give me anything. Nothing happens, right? So um, that's if-else statements. And what if you have multiple conditions that you need to check? So let's say you have one condition, and if that's true, you need to do one thing. If you have another condition that's true, then you need to do another thing. So you have multiple conditions, and you want to do multiple things if one of them is true, and you use something that's known as an if-else-if statement. So you say if B is greater than A, then you print B is greater than A. Else, you also want to check if B is equal to 20. So elif in Python basically is short for else if. So this tells you this is basically another condition, and then the last one is if neither of these are true, then you do this. So to summarize, you can use else ifs to compare a lot of different conditions and uh, make make whichever choice you want to make in your program using these conditions. So basically, if else if is used to it's used to select a branch of instructions that you want your computer to follow based on whichever conditions that you give to it are true or not. So, and it doesn't need to be just three. You can have as many elifs as you want here. You can add another one. You can add as many as you want, different conditions. So now that you know about if else if, can you write a program that would print the maximum of three given variables? When you're ready, you can click the answer to read the solution, but I really recommend you try this out first. You don't look at the answer. You try this out and see if you can write a program that would print the maximum of three variables. So oops, if I have A equals to something, B equals to another variable, and C is equals to 30, then you should be able to write a program that can find the maximum of the three variables. Also, another thing to note is in Python, if you want to take a number as an input from the person that's running your code, then you use this function that's called input. You say input and enter the first number, and then the second one use oops, and when you do this, you'll get whatever value that the user enters. So you can take input from the user using this thing. So I can enter, say, 15, I can enter 24, and I can enter 78. And then those numbers, they're taken from the command prompt itself. So you can write programs that have variables that take values from the user. So it doesn't have to be written in the program from the start. When you take this input, right, it is given the variables are strings. So when you take this input, A would be a string, B would be a string, and C would be a string. So when you do, if you try to do a operations on them, uh, you first have to convert them to integers. So to do that, you can use int, and you can use the int function. It basically takes in a string and it uh, converts it to the integer value. And instead of using an int here, actually float would be more appropriate because you can have a fractional input as well. So if you use the float function, then it it converts the string to a float or any data type that you specify there. So now if I run the program again and I type in my values, they're going to be displayed as floats. Now you can see they have a 0.0. So yeah, now it's yeah, you can try this problem, and when you're ready with the solution, you can move on. Okay, if you've managed to write the solution, and let's take a look at the answer. So it's basically using an else if OO, and that should say elif, not else if. That's wrong. But yeah. Um, Yeah, so you write if you first see if A is greater than B and C. So you check if A is greater than B and A is greater than C. And if that's true, then the maximum is A, right? If it's greater than both of the other numbers, it's the maximum, right? The second one is the same with the B. So B is greater than C and B is greater than A. If B is greater than both of the other numbers, then it's the maximum, right? So that's the case. And if neither of these are true, right, then the only other possible case is that the C is the maximum number. So if A and B are not the maximum, then only C can be the maximum, right? Because one of them has to be the maximum number. So this is how you use if else if to find out the maximum of three numbers. Okay. Okay, then we come to loops, and loops basically they allow you to repeat an instruction again and again and again. And like so, loops is quite something that you do in everyday life as well. So there are times when you want to repeat a certain action, and you kind of use a loop. For example, let's say you're playing a game and you're in a boss fight or something, and you're not managing to pass the level. Then you'd say while you have not defeated the boss, then you try again, right? So while you're stuck at the level, you keep trying again until you make it through. And let's say you want to write the two times table, say the two times table, then you would say something like for every number between 1 and 10, write two times the number. So that would give you the two times table, right? So it's something that you do again and again and again and again, and only some things change. So you use a loop. And the same idea is like it comes over to programming. And in Python, we have these two things known as a while loop and a for loop. And the while loop basically repeatedly executes a block of code as long as a condition is true. So it's literally while something is true, then it'll execute the instructions inside. So for this one, while A is less than 10, it'll keep running the code. So what will happen is it'll print the value of A, then it'll add 1 to A, and it'll do that until A becomes 10. So if I run this, oh, there's a mistake here. It should be string. So we do this, and it gives you all the numbers from 0 all the way to 9. And know that since I used A is less than 10, 10 is not included in the final result because 10 is not less than 10, it's equal to 10. So on that case, the condition fails. And if I print the value of A outside the loop, you'll see that it's 10. So if I print A, then it gives me 10. So when this condition becomes false, then it stops looping whatever you have inside the block. So now that you know about the while loop, can you print the following pattern up to 15 terms? Sorry?
Trying to figure out what's the pattern because how does 7 relate to 1, 2, and 4?
You can think about it, but so if you don't want to see the full solution, but you want a hint for a pattern, you can click hint and it will tell you what the pattern is, but it will not show you the complete answer. So if you want to do that, you can click hint. Uh, but I recommend trying to figure it out on your own first. If you really can't, then you look at the hint. And wait for 2 more minutes while you try, and then we move on. You can look at the hint if you still. Oh, okay. Okay, I think you should move on. If you manage to solve the problem, then that's good. If not, then we'll go over the solution now. So basically, the way to do this is you need to notice that a pattern to the numbers is that each time the increment of the numbers or the amount by which they increase, it also increases by one. So the first time you add one, you get two. The second time you add two to two, you get four. The third time you add three, you get seven. Then you add four, you get 11. You get add five, you get 16. So each time you're adding a bigger number than before. And the way that you would write this is uh, basically you also keep track of the increase, and then you start at one, and each time you increase the number by the increase, and you increase the that value itself as well. So now if I run this, it'll print the, the pattern that oh that's the this should be string, not. So an important thing to know is in Python, you can't concatenate a string and an integer. So if you have an integer and a string, you can't combine them using the plus operation. That would give you an error. And that's what happened here. So to fix this, you would need to convert the int to a string, and you do that using the str function. So now that, yes. Okay, let's move on to the for loop. So for statement is specifically used to loop over a range of values in Python. So let's say you want to print numbers in a particular range, then you use the for statement to do that. So I can type for a in range 2, 23, and then print. And once again, this should stay str. To say str, not just it, so that doesn't work. So uh, yeah, so this one it starts at 2 and it ends at 22. So the number that the ending point that you specify is not included in the range. So it will go from 2, 3 all the way to 22. So if I comment out the others and just print this one, you see it goes from 2 all the way to 22. Then the next one is you can also go backwards. So if you want to go from 10, 9, 8, 7, 6 all the way to 0, then you can also do that. Note that the 0 here is also not included. So it would end at 1. Yes. If I print, I also, yeah, no, I saved, but I forgot to specify the, I also need to specify that it has to go in the opposite direction. I forgot to write -1 there. So when you want to go in the opposite direction or in the opposite direction, you need to say -1 in the step. So basically the range, it takes 3 values. It takes a starting point, it takes an ending point, and it takes a step. And basically the step tells you how much to add to the start until you get to the end. And if you don't specify the step, then it's automatically chosen as +1. So if I did 10, 0, then it wouldn't work because it's like 10 is already greater than 0, so it would not increase. So you need to specify -1 there, and this should give me values all the way from 10 to 1. So sorry.
But if you put a one there, one, oh, it's +1. Oh, it's a minus.
Yeah, it's a -1. So by default, it would be just +1. So you can have any number as the step size here. So it works similar to how slicing works, but instead it's with numbers. So you could have 10, 0, -3, and it will start at 10 and it subtract 3, and so it skips every 2 numbers. So, oh wait, what? Oh, I uncommented the comment by mistake. So you get when you run this, you get 10. When you subtract 3, you get 7. Subtract 3, you get 4. Subtract 3, you get 1. So the values decrease at a decrement of 3. You can use any kind of step size that you would want. You can use 0, 105, and go all the way from 0, 5, 10, 10, 15, 20, all the way to 90. For can be all. You can also use for loops to go through all the elements of a list, a tuple, or a dictionary. So if you have a list, if you have a tuple, or if you have a dictionary, using the for loop, it will go through each of the values one by one. So this one, if I print, it goes, it takes 5, it gets assigned to number, and then you print the numbers with 5. Then it takes the second one, which is 3, gets assigned to number, and you print the numbers, so 3 gets printed, and all the way to the end of the list. It's the same with a tuple. If I have a tuple and you can print all the values in a tuple using a for loop, then it's the same thing with a dictionary. If you have a dictionary, then looping with for, it'll go through all the keys of the dictionary. It doesn't go through the values. It goes through the keys of the dictionary. So here, if you want to print the values of the dictionary, you would have to uh, actually give the key to the dictionary to be able to get both the value as well as the key. If I just use key, then I don't get the values of the dictionary. I just get the keys, which is uh, 3.14 pi and SpongeBob. So I don't get the values associated with them. So to get the value as well, you need to specify both of them. Okay. So if you want to get the values, there's actually another way to do it. So you can say dictionary dot values, and this would give you the values now. So if I print, this would give me all the values in the dictionary. And using the same way, you can do dictionary dot keys. That will give you all the keys of the dictionary, but it's just kind of redundant because even without the keys, you get the keys, so you don't need to do this. And if you want to get both the key and the value, you use dig.items, which gives you every key value pair, and it gives you the key value pair as a tuple. So if I print key, it'll print each of the key value pair in the dictionary as a tuple. So I could say here key comma value, and that would give me, and I didn't print the value. This would give me the key and the value pairs as well. Does this make sense? So with tuples, you can do this thing in Python that's known as tuple unpacking. If I just comment this out for a second, if you have a tuple that has um, multiple values inside, you can assign them to variables using this thing known as tuple unpacking. So you can say B, comma C, comma D is equal to A, and then the first element gets assigned to B, the second one gets assigned to C, the third one gets assigned to D. Does it make sense? So now if I print B, C, and D, I get 1, 2, 3. So when you do the same thing in the for loop with the dictionary of items, it's the key value pair inside a tuple, and you use this thing called tuple unpacking to give the key to it assigns the key to the first one and a value to the second one, and then you print them. Okay, so that's all about loops and conditions and flow control in Python. Then we move on to functions. So basically, functions are also a really important part of any programming language. It's not just Python. So let's say you're watching TV and you want to change the channel on the TV. You every time you want to change the channel, you'll use the same remote, right? If you can't, it doesn't make sense for you to get a new remote every time you want to change the channel. That would be quite wasteful. So similarly in programming, right, when you want to write a piece of code that you know you want to use many times, then instead of writing it out many times in all the different places, you write what's known as a function, and basically the function you can reuse the same piece of code anywhere that you want. So for example, I have a program here that finds the maximum number in a list. And this is okay if you want to find the maximum of one list, but let's say I have 100 different lists and I want to find out the maximum in every list. Is it feasible to write the same code 100 different times? No, right? You don't want to do that. So the way you do that more effectively is using functions. So instead, now you write the same code inside a function, and now you can reuse it as many times as you like. So basically, this line at here is known as a function prototype, and it's what defines a function. So the def right here, right, this def, it um, it's short for define. So you're defining a function here, and max value, this is the name of the function. So you're saying I'm defining a function that's called max value, and this takes in a list of numbers. So you take in a list of numbers, which now you're now going to find the maximum of. Okay, does it make sense? So now you can find the maximum value in this list, and once you find the maximum value, you use this thing known as a return, and you return the maximum value to wherever the function is called. So let's say I copy this code in here, and now I have three different lists here, and I'll find the maximum. To find the maximum in each different list, all I need to do is just call the function using that list. So the first one, I call the function using the function's name, and then I give it the list that I want to find the maximum of, and it'll it'll find the maximum for me basically. And this, you can see, like, I don't have to rewrite the same code three different times. I just use the function. It's more convenient to do it this way. It also makes your code more modular, and it's more readable. So let's say I have this list here, right? And I want to sort the list. If I write code to sort the list, then is not as effective, because if somebody is reading your code at a glance, then they'll have to first read and understand, and then they'll know that, okay, this code is sorting the list. But if you just write list dot sort, it's immediately obvious that the list is going to get sorted. So functions are really, really useful, and you should use them as much as you can when you write code. So if I run this, it'll find the three maximum values in the list, which is 88 in this one, it's 90 in this one, and 96 in this one. So 88, 90, and 96. Then a function doesn't have to necessarily return a value. It doesn't need to have this return statement. So you can have an element, you can have a function that just does stuff but doesn't actually return a value. So this is just going to print out all the different lists. And I didn't save the file. So now it prints out all of the different lists. What's this none? Why do I get a none value here? I'm printing out all the lists, but none doesn't make sense. There's no none in my list. Why is there a none here? This is because, remember that the function is not returning anything, and I'm printing the value of the function. And when I do that, it doesn't actually have anything to print because my function didn't return anything. So it just prints none because it doesn't have anything to print. So you should remember that if a function doesn't have a return type or any returning statements, then it doesn't give you any values. Also note that if you encounter a return statement anywhere in the function, then the rest of its code does not get executed. So as soon as you reach the return line, it just skips everything that comes after. So if I have this code, then if I write this, then it would just give me 10, which is, it skips everything that comes after the return statement. So that's functions. And now that we know about functions, can you write a function to calculate the factorial of a number? Use the function that you write to then find the factorial of the first 20 numbers. Okay, let's take 5 minutes to try and do this problem. And if you don't know what a factorial of a number is, a factorial of a number is given by the product of all of the numbers that are less than it up till 1. So 5 factorial would be 5, 4, 5 times 4 times 3 times 2 times 1. 3 factorial would be 3 times 2 times 1. So we can find a factorial of a number that's given by this formula. So factorial of 20 would be 20 times 19 times 18 times 17 times 16 all the way to 1. Okay, if you manage to solve the problem, then that's nice. If not, then we'll go over the solution now. So, so basically, we write a function that's called factorial, and it takes in a variable called a, and then we also define another variable called factor that's used to calculate the factorial. So next, you say for I in range of 1 to a plus 1. So basically, from 1 to whatever number that you've been given. So instead of writing axt, you should use number to be more clear. So now it's going from 1 all the way to the number. So it's going to multiply every number to factor, and it's going to return that. So is when you do this, let's say if number was equal to 5, then um, your for loop would look something like for I in range 1 to 6, and then this would be, so initially your I would be 1, so it would multiply 1, that's just 1. Then it would be, the I would become 2, and it would multiply 2 to factor, which would make it 2. Then uh, I would become 3, and then 3 is multiplied to factor, which becomes 6. So that goes on and on until 5, and you get 120. So to actually more clearly, let's say going to write this one out. I think it again, makes it a bit more clear. So I have my I have factor, and so what happens first is I have one for factor for I in range 1 to the number. So it goes from 1 to whatever the number is. Let's say the number in our case is 5. If and I is it starts from 1 and goes to 6. So 1, you get 1 and you multiply 1 to factor, you get 1, still 1 doesn't change. Then you have 2 for I, then you multiply 2 to factor, you get 2. Then you have 3 for I, so you multiply 3, then it becomes 6. Then I becomes 4, and you multiply 4 with 6, you get 24. And finally, I is 5, and when you multiply that factor, it becomes 1. So, and then it ends because it only goes from 1 to 6, and 6 is not included. So you get 120, and that number is returned. So, and now you see that since we wrote a function for doing this, I can now reuse the function as many times as I like, and using the function, I can find a factorial of all the numbers going from 1 to 20, and they all printed here. So functions are really useful when you want to do the same task over and over again on multiple inputs. Okay, then we have type hints with functions. So basically, what type hints do is when you write a function, you can specify the data type, the expected data type of each variable in your function. So when you write the function now, you say you define a function that's called calculate BMI. So it's going to find out the BMI. And to find BMI, you need the height of a person and you need the weight of a person, right? So the height is going to be a float and a weight, let's say, is going to be an integer value. So you can tell the function that, oh, I expect a float for height and I expect an integer for weight. So and by doing this arrow float here, right, it tells the function that it's going to be returning a float value. So the value that you return, it will be of a float data type. So it is important to give type hints for your functions because when other people use the functions that you write, they should be able to know which kind of data types they need to provide to your function, right? So it's important to use type hints when writing functions. And lastly, with functions, we get to recursion. So recursion is basically is it's if you have a function and you call the same function inside of that function, then it's known as recursion. And let's understand recursion by using the example of the factorial once. So we previously we learned that n factorial is given by n times n minus 1 times n minus 2 all the way to 1, right? Similarly, you can, if I write n minus 1 factorial out, n minus 1 factorial would be n minus 1 times n minus 2 times n minus 3 all the way to 1, right? But if you notice, this and this is exactly the same, right? So what you could do here is say that n factorial is equal to n times n minus 1 factorial, right? You can write it out like this. And using this, right, you can actually, if you know, if you know, this is quite useful because if you know what 4 factorial is, right, you can immediately calculate 5 factorial because if I tell you that 4 factorial is 24, then you can find 5 factorial just as 5 times 24, one which is 120, right? So this is when you have something that's defined in terms of itself. So if you say that n factorial is equal to n times n minus 1, is known as a recursive definition, which means it's defined in terms of itself. So you have a factorial here, you have a factorial here as well. So if you were being introduced to the factorial for the first time, right, and somebody told you that n factorial is equal to n times n minus 1 factorial, is that actually enough information for you to calculate the factorial of any number? Mm, yeah, it doesn't tell you where to stop, right? So you don't know when to stop with this. So you can go n minus 1, n minus 2, n minus 3, all the way to where do you stop? You don't know, right? So that's not all the information that you need to complete the definition of a factorial. You need a stopping point. And the stopping point is actually 0 factorial is defined as 1. So 0 factorial is 1. So now when you know that 0 factorial is equal to 1, you can say that for all numbers that are not 0, you can use this. And when n factorial you have 0, you use 1, right? So then you have that if you would try to calculate a 3 factorial, without a stopping point, you could just keep going and going and going, and you don't know where to stop. But once you know the stopping point, you go all the way down. So you want to find 3 factorial is 3 times 2 factorial. Then you want to find 2 factorial is 2 times 1 factorial. And when you want to find 1 factorial is 1 times 0 factorial. And now you know that 0 factorial is 1. So you use 1 here, and then you just, when you find this, you use it here. When you find this, you use it here, and you get the value for 3 factorial. Right? So does this thing where you need a stopping point for recursion, this is known as the base case of your recursion. So if you say n factorial is equal to n times n minus 1 factorial for any number that's not 0, then that's known as the recursive case, and the 0 factorial equal to 1 is known as the base case. So using this, you can find out if you know the factorial of a smaller number, or if you have the factorial of a bigger number, you can work out the factorials of any number that you like using this definition. And this process of defining something in terms of itself is known as recursion, and it's important in programming, and it's a lot of any programming language. Recursion is a super important thing because it allows you to solve problems by breaking down the problem in terms of itself. So, for example, I think you've probably heard of this thing before, but you've played a game where you have three like, pillars, and you have around those pillars you have rings of different sizes. So you have a big ring at the bottom, and a small ring, and an even smaller ring. Yes, towers of Hanoi. So this is known as towers of Hanoi. So you've probably heard of this before, and basically the rules of the game are that you want to move the whole stack from one pole to another pole, and the rule is that you can only move one ring at a time, and a bigger disk can never sit on top of a smaller disk. So you cannot have something like this. It should be invalid. So to solve this kind of towers of Android, if you want to move it from one pole to the other one, how do you do it? So you say, okay, if I can somehow work out a way to move the two rings here, then I can move the third biggest ring, and then I can move the two rings again, and I will solve the problem. Does that make sense? So I say if I knew a way to solve the problem of two rings, I would work out the solution for three rings as well. And how do I solve it?
Easier said than done.
Sorry?
No, it's easier said than done. I never figured this out.
So this is actually an interesting application of regression, because you see you started out with a problem that's with three rings, right? And now we're down to a problem with two rings. And now you want to figure out, can I solve this for two rings? Let's see. So if you now have a setup with two rings, can you solve this for two rings? It's quite simple, right? You just move the first one, then you move the second one, then you move the first one again, and you just move the whole stack over. So you figure out a way to solve it for two rings. Now can you do it for three rings? Yes, right. Because you know how to move the two stack over. So you do the same thing. You say that you move this for three rings. You move the yeah. Sorry. So remember again that the way to solve this is to first move the two rings to this one, then move the third one to the last one, then move the two rings to the last one again. So how do you do that? You use the solution from just two rings. So you move the smaller ring here, you move the second, the medium sized ring here, then you move the smaller one over the medium sized one. So you solve the problem of two rings. Now you move the third ring to the second one. So now using the same method, you move these back onto the biggest disk. So you would move this here, you would move this here, and then you remove the smallest disk here. It's kind of getting messy with all of the things, but I can show you a really nice animation for Towers of Hanoi. Let me see if I can find the animation that I have. Oh, wait, it's not in here. Yes, here. So, believe this is the animation. Yes, it's the animation of the thing that you're just talking about. So you solve the problem for two disks now, you move the third one, and now you solve the problem once again for this one. So now you move the two disks back, and now you move the third one. And now you're going to do the same process again. So now you again move two, and you move the third one, then you move these back, and yeah, now you moved all the four disks. Does that make sense? And there's actually a really nice relation to binary numbers. If you notice, this is actually counting up in binary. So if you follow the colors of the digits, then whenever the digit changes, that's when a disk moves. There's a really interesting relation between towers of Hanoi and counting and binary. It's interesting. So factorial in terms of as a recursive function is shown here. So you know that whenever the number is not zero, it's the number times the factorial of n minus 1, right? So you use that definition of the factorial, and when you have zero, you return 1. So now this function can calculate factorials recursively. That makes sense? So let's maybe walk through an example so this can be more clear. See, I think I have an example. Yes. So yeah, there's an example problem that I would like you to attempt. So you can try figuring out what this piece of code should output. And you're not allowed to type this into your IDE and run the code because that would be cheating. You have to work this out by hand. So try to figure out what this recursive function would print. And keep in mind that every time you have a function call inside a function, it stops everything that it's doing and it goes into it it first does the task of the function call that you made, and then it basically, if you have a function call inside a function, it stops everything that it's currently doing. It'll first complete the task of the function, and then it'll resume its own operation after that. Okay, let's take maybe 3 minutes to figure out a solution. If not, then I'll move on.
This is not the, this is not the code.
No, this is not the factorial. This is the factorial is just used as an example. But this one is does something different.
Comes down.
Sorry.
Comes down.
Also remember that when you make the recursive calls to a function, right, it stops the rest of the thing that it's doing, but it doesn't completely forget about it. Once it's done with the function call, it will still continue with the code that it left earlier. So when you do this, right, when it does this function call, it'll hold the print, but it'll still execute the print statement once it's done with whatever it's doing here. So make sure that when you're thinking about this, you don't forget about what's coming after the function call.
One, one.
Sorry?
Get one.
Yes, I think that's correct. Yeah, there's a zero in here. Yeah. Yeah, there's a zero in here as well because when when the number is greater or equal to one, the recursive call is made. But when it's equal to one, there's still a call number minus one. So zero goes in. It doesn't execute this part, but it still goes through the print number. So it still gives you a zero here. So that's how like if yeah that's like classic example for recursion. And with that, we come to the end of functions, and we're going to go over classes and objects, which is also like one of the really important concepts for programming. And basically, when you talk about classes and objects, right, is let's say you come across like a lot of different objects in your daily life. If each object that you come across has a different like it has different properties, it has different things that it can do. So let's say I have the marker here. The marker, it has red ink in it, it has a size, it has some weight, so it has some properties, and it has a function you can write with it. So the marker can be used to write with. So with every object that you see in real life, right, it has some properties, it has some functions that it can perform. A chair, it has some weight, it has some height, it has a material that it's made of, and so like all objects are like that. And what would you do if you wanted to represent uh, an object like that in a program? How would you define its properties? How would you define what kind of functions the object can execute? So you might try writing something like this. Let's say I wanted to write an object that's a pen in code. You might try writing something like this. So the pen has a color, the pen has a size. It's either a ball pen or it's a gel pen or it's a fountain pen, and the pen might have an owner. So there's that. And then you write a function that can display all of the information about the pen. So it can display its color, size, kind, and owner, right? But this, it works for one pen, right? What if I wanted to make 100 different pens? Can you write the same piece of code 100 different times? That's not feasible, is it? That doesn't make sense. So, and you can't scale this up to a large number of objects. And if you had an unknown number of pens, like if you wanted to make some amount of pens that are determined when the code is actually being run, then you can't use this because you don't know how many variables to make. But this is where like classes and objects come into the picture. So classes and objects, they are basically what we call as user-defined data types. So in Python, integers, floats, lists, all of these data types that we learned about, they are primitive data types. They are built into Python. So they're you can use them without having to define any classes for them or any objects for them. But if you wanted to make your own data type, then you'd use a class, you'd use an object to do that. So basically a class is a custom data type. And yeah, with that we move on to what classes are and how we use them. So now we want to create our own data type, right? We want to make maybe a pen, or we want to make something more complicated. Then that's what classes allow us to do. So a class is basically a blueprint for creating an object. It tells us the defining properties of the object, and it also tells us what functions the object can perform. So a class, I repeat, it's a blueprint to make the object. It's not the object itself. So a class for a pen object would look something like this. So this tells me that the pen, it has a color, it has a size, it has a kind, and it has an owner. And um, the class also has a function called display information, which shows the information of the pen. So it will show me the color, the size, the kind, and the owner. And note that this funny function that I have here, right, underscore underscore init underscore underscore, this thing is known as a constructor in general. So this constructor is essential for every blueprint to have a constructor, because it's literally the constructor is the function that actually constructs your object. Without this, you won't be able to make objects in your class. So let's say you have a blueprint to make a bicycle, right? You could have the weight of the bicycle, you could have the height, you could have the material that it's made out of, you could have certain properties like, does the bike have a bell, does it have a basket? But you have all of the properties written down on a blueprint, but you don't have the tools to make it. You don't have a wrench, you don't have a hammer or something that you would need to make a bicycle. Then you would not be able to make it. So basically, the constructor is the tool that you need to make an object, and it's required in every class. So with the constructor, you also in a class you also define other functions that the object can perform. So this class also has a display information function that shows you all of the details that a pen, all the information that a pen has. So remember that a class is just a blueprint for creating a pen. It tells us what properties and what functions it has. It's not the pen itself. To actually create a pen, you would use the blueprint and you would specify all of the properties, something like this. So you say that A is equal to a pen, and you specify that its color is red, its size is 0.5, the kind is a marker, and the owner's name is John. So now you make a pen object like this. So when you do this, the Python calls the constructor and says that, construct me a pen with the following properties. It has to be red, it has to be of size 0.5, it has to have the kind of the pen is a marker, and its owner's name is John. Does that make sense? So this syntax is used to construct a pen. And then if you want to see the information about the pen, you can use the display information function like this. You say a.display information, and that will show you all of the properties of the pen. So I can copy the code and run it. Just for the first pen, see that when I run this, it shows me the color, the size, the kind, and the owner. So, and now when I have the class, now if I want to make multiple objects, right? If I want to make 4 different objects, then all I need to do is just use the same syntax with the constructor, and I will have 4 different pens. I don't need to make 4 different variables for every pen, which is quite tedious to do. If you wanted to make 100 different pens, it's much more efficient to do this. Right? So now, if I run the program, then it'll give me it gives me all the information about all of the 5 different pens. And wouldn't you say that this code looks really neat and nice because you can immediately tell at a glance what's happening. You're making 4 different pens, you're displaying information about them. It's like quite obvious as to what's happening with the code if you were to read somebody else's code. So classes and objects, they are really, really powerful for you to be able to it creates really modular code. It creates really highly readable code. So you should use classes and objects as much as you can. Okay? Does this make sense? Uh, do you have any questions?
We have an easier time to recognize it. Limited more descriptive and less maybe put a bonus name instead of
Yes, you can do that. I mean, like I said, the choice of
okay, bonus name in lowercase.
yeah, you can definitely do that. So it make the
Practical way. I mean,
yeah
this is just because it's testing.
yeah. In practice, it definitely makes sense to use more mnemonic variable names that are descriptive and like they should tell the user what they're supposed to do and not just ABCD. That obviously in practice this doesn't make sense. Since this is just an example, so and work with it. Okay, so right now the class that we saw was it uses it breaks some conventions for the sake of an example. But more conventionally, right, a class it would look something like this. When you define a constructor, if you notice in the original class, I in a constructor I use different variable names from the properties, right? And I call the first variable in my constructor and a variable in my uh, display information function, I call it pen, right? But conventionally in Python, you call the first the object that's passed to the function. You call it self, and all of the properties that the object has, you use the same name for the property as the one that the object has. So this the color over here, the size over here, the kind and the owner, this all refers to these variables. And the self.color, the self.size, and the self.kind, these refer to the properties of the object. So if you don't have a self, then it just refers to these values. And uh, conventionally, you use the same name for the both variables, but you don't have to. As you see, you can use different names. And it's conventional to use self as the name of the object when writing the functions. So you don't have to use self, but again, you can see that it's so important to follow this one that it actually has its own color. Like Python colors it differently from other variables to show how important this value is. So yeah, you should really follow these two conventions are quite important when writing classes. So with that, uh, we have uh, a, a practice question. So you want to write a class that describes a bicycle object uh, which has these mentioned properties. So you can think about how you go about writing these and make a class out of these. So let's take maybe 3 minutes to do this question, and then we move on. Okay. Yeah. Okay, if you managed to do the question, and that's good. If not, then we'll go over the solution now. So the goal is to write a class with the following properties. So the bicycle object should have a color, it should have a material, it should have a size, it should have a height of the seat, it should have a gear ratio, the diameter of the wheels, and it should uh, and you also have properties for does it have a basket or does it have a belt. So and the bicycle also has two functions. You can change the gear of the bicycle, and you can adjust the height of the seat of the bicycle. So you write it out something like this. So you say you're making a class that's called bicycle, and you define the constructor for the class, and the constructor has these properties. So it has a color, it has a material, it has a size, uh, it has a size, it has a height, it has a gear ratio, it has a diameter, it has a and then the two properties for does it have a basket or does it have a bell or not. So these are going to be probably Boolean variables that can be true or false. So if it has a basket, then you make that true. So And then the class also has two functions for changing the gear ratio and adjusting the height of the seat. So to use this class, I could copy the code and then you'd make an object, say bicycle, and then you can give it a color. Let's say it's red. Then let's say uh, it's made of aluminum, and it has it's maybe say it's a small bicycle. Then it has a height of 1 meter, maybe. Then you have a gear ratio. Let's say it has a gear ratio of 2. The diameter of the wheel could be 10, or maybe zero point 0.5. Actually, 10 is not too realistic. But the last two properties, it could let's say it doesn't have a basket and it does have a bell. So say false and true. So now I have a bicycle object that color is red, the material is aluminum, the size is small, and its height is 1. The gear ratio is 2. The diameter of the wheel is 0.5, and it doesn't have a basket and it has a bell. And now if I do cycle dot change gear and I set the value to, let's say, 4.5. So if I print cycle dot gear ratio before and after the function is going to be it's going to change to 4.5. So now that I print the values, you have first is 2 and then it changes to 4.5. Okay, so now we move on. So, what makes classes so good with code? So, classes are they're incredibly reusable. So, you saw earlier that you can make as many objects with a class as you like. It's incredibly modular as well. So, you can reuse a class as many times as you want, and the code is incredibly more modular and it's easy for a programmer to debug the code when there are bugs in a proper class and an object-oriented program. It's the code is also more clear as to when like it's easier for others to read your code and understand it because of the high modularity and using functions. It's also better organization for the class because your data can be clearly and neatly organized for more complex objects. Let's say you have an object that has like 100 different properties, then it's so much more nicer to have it as an object than 100 different variables. So is better with organization, and it also allows for something known as data abstraction. So data abstraction is basically the process of hiding the implementation details of something from the user and allowing them to focus on the functionality instead. So for example, if I have a list of numbers, right, I have 4, 2, 1, 55, 2, 3, something like this, and I want to sort the list. I can sort the list just by saying list.sort. And now when I print the list, my list will the values are in increasing order. So I don't need to know how that sort method is implemented. I just know that it works and I can use it if I want to use it in my program. So that's basically abstraction because I'm hiding. Python has hidden how sort is working internally. So this just provides us the functionality of the feature. So it's also incredibly useful for that. And is also the same thing is it applies to objects in your life, like daily life as well, like your smartphones. You don't need to know how the smartphone is wired internally. Like you don't need to know how the circuits are connected to be able to use a smartphone. You can still use a smartphone even if you don't know that stuff. So it's an incredibly useful concept. And lastly, an object, it can also have other objects as its properties. So if you have class, I have a class pen here and a class pencil, and then there's a class stationery. So the stationery has a pen and a pencil as its properties. So an object can have other objects as its properties as well. Okay? So, and with that, we come to the end of the session. There is still one part that it seems like you won't be able to cover because we ran out of time. But you can go back and like read the next part on your own and try to understand it. But we did cover most of the important concepts for Python and programming in general. So I hope that after today's session, you go back and like try more of these kinds of problems and learn more about programming. If you have any questions, you can ask. And with that, we come to the end of the session.
Any textbooks you recommend?
Uh, I, I, I wouldn't recommend any textbooks per se. I'll say there's a website called w3schools.com for any programming language in general. It has a reference for Python. I can't find it here. So I'll recommend this website for Python, and it has other programming languages as well if you're interested in learning those. So you can go to the website, and it has quite a like it has a lot of different topics, and it goes into much more detail than I had time to cover today. So if you're interested to learn more, you can go to the website and learn more about Python. And for any programming language, it's much, much, much more efficient to learn by doing problems and trying to write code on your own than reading from a textbook. So I highly recommend you try to do problems. You like take a you can look at different questions online and yeah, try to get as much practice as you can. That's the key to um, having an effective knowledge of any programming language. Okay, with that, we come to the end of the session, and there's this QR code that you guys can scan uh, for sharing some feedback. And there's you can find more information about a wide range of training courses and resources at the MySkills Future website. So if you're looking to upgrade your skills for a career or progression or transition, but you're not sure on where to start, then you can speak with Skill Futures, Singapore's skills ambassadors, and to identify your skill needs and gaps and gain useful tips and advice on how to kickstart your skills search. you can scan the QR code to find out more about this.